Welcome back for lesson 46. We are solving problems using scientific notation. Okay, and you've got objective 1 written up here. Our first objective is to multiply numbers in scientific notation. Alright, and we've got our steps over here, so we're going to go ahead and follow them. So we'll start with part A. Okay, and sorry, I need my thicker pen that I like here. So, first thing I'm going to do is write down the problem. Okay, so it's 1.2 times 10 to the 5th, and we're taking that times 3.0 times 10 to the 5th. Okay, so step 1 is to multiply the numbers. Okay, so the numbers that I'm multiplying are 1.2 times 3.0. So I'm going to take 1.2 times 3.0, and that's going to give me 3.6. Okay, step 2 is to multiply the powers of 10. So now I'm going to take the second part, so the 10 to the 5th, and multiply it by 10 to the 5th. Well, remember, when we multiply a number with the same base raised to an exponent, we keep the base and we add the exponent. So it's 10 to the 5 plus 5, which is equal to 10 to the 10th. Now I'm going to write those in scientific notation. So now I'm going to combine this number and this number to make a number in scientific notation in my final answer. So I'm going to put 3.6 times 10 to the 10th power. And that's my answer for A. Okay? So we've got our number, and it's written in scientific notation. We know that because this number is between 1 and 10, and we got times 10 to some power. Okay, so we multiplied the numbers together, then multiplied the powers of 10, and then combined that into a new scientific notation. Alright, and let's do example B. So same thing, we're going to do 4.0 times 10 to the 4th. And we're going to multiply that times 5.0 times 10 to the 5th. Okay? So first step is to multiply the numbers. So I'm going to take 4.0 times 5.0. Well, that's the same as 4 times 5, that's 20. Okay? Then I'm going to multiply the powers of 10 together. So I'm going to have 10 to the 4th times 10 to the 5th. And that gives me 10 to the 4 plus 5, or 10 to the 9th. Okay? Well, now I'm going to combine those numbers, okay, 20 and 10 to the 9th, and put them in the format for scientific notation. However, this is not scientific notation because this number needs to be between 1 and 10. Alright, so I need to put a decimal in somewhere where it's going to be between 1 and 10. Okay, well, the first thing I'm going to do is I'm going to go ahead and write this number out, okay, in standard form. So 20 times 10 to the 9th, that means 20, and I move the decimal over 9 spots, okay, which would be 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's 4, 5, 6, 7, 8, 9 zeros. Okay? So that is this, or this number is this in standard form, 20 times 10 to the 9th. So now I need to write that in scientific notation. So I am going to write this number right here in scientific notation. So it's going to be 2.0, or just 2, times 10, and if I put the decimal right here between the 2 and the 0, there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 digits after the decimal. So 20 times 10 to the 9th is the same as 2.0 times 10 to the 10th. And this one is in scientific notation correctly because this has to be between 1 and 10. Okay, so that's step 3 where it says to write the number in scientific notation, you need to make sure this first number is between 1 and 10. Alright, let's go on to another example. Okay, example 2 says light travels at a speed of about 300,000 kilometers per second. An hour is 3,600 seconds. We want to write both numbers in scientific notation and then estimate the distance light travels in an hour using scientific notation. Okay, so first thing we need to do is figure out what kind of problem this is. Light travels 300,000 kilometers every second, and we want to know that's in an hour, so we have to multiply those numbers together. So we're going to take 300,000 times 3,600. Okay, it says to write both numbers in scientific notation, so we're going to do that. We're going to take 300,000 and make it 3.0 times 10, and if I put the decimal in here, it would be 5 spaces after the decimal, so times 10 to the 5th power. And we're going to take that and multiply it by, well, in this number I'd have to put the decimal between the 3 and the 6 to make a number between 1 and 10, times 10 to, and if I put the decimal in here, that's 3 spots after the decimal. Okay? Well, we're going to use scientific notation to multiply these numbers. So we're going to take the numbers first, and we're going to do 3.6, or sorry, we're going to do 3.0 times 3.6, and when I multiply those, 3.0 is the same as 3, 6 times 3 is 18, and I carry my 1, 3 times 3 is 9, plus 1 is 10, and I need 1 decimal place in my answer. So that's 10.8. Then I'm going to take 10 to the 5th times 10 to the 3rd, and that's going to be 10 to the 5 plus 3, which is 10 to the 8th. So if I use both of these numbers, I'm going to have 10.8 times 10 to the 8th. Okay? Now we've multiplied using scientific notation. Okay, so we've used scientific notation. Now, it wouldn't make too much sense for us to write our answer in scientific notation if we have, don't have a whole lot of zeros to add on the end when it's a real-world application problem. But we can. So we're going to go ahead and write this in both forms, our answer. Okay, we're going to write our answer in scientific notation and in standard form. Okay, so we can see what that number looks like. So 10.8 times 10 to the 8th, that is not correctly written in scientific notation because of the 10.8. So I'm going to write down 10.8, and the 8 tells me how many spaces I need after the decimal, or how many times to move the decimal. So I have to move it 1, 2, 3, 4, 5, 6, 7, and fill in some zeros. And my number now looks like this. Okay, and actually, sorry, I should have one more 0 there. Because again, we have to go 1, 2, 3, 4, 5, 6, 7, 8, not 7 places. So here's my number in standard form. Okay. Well, if I want to write that in scientific notation, again, we're going to have to put it as 1.08. So we have to put the number in between these two to make it between 1 and 10. And then I have 1, 2, 3, 4, 5, 6, 7, 8, 9 places after the decimal. So it's times 10 to the 9th power. And we have to have a label. It's in the distance. So it's in kilometers. Or I could also use, again, this number in standard notation and rewrite it. Okay? So we can say it's 1.08 times 10 to the 9th, or 108 with 7 zeros after it, and put in some commas. Okay, so that's 1,080,000,000 kilometers. And the reason why, again, it might not be bad to write this in standard notation this time instead of scientific notation is because there's not a whole lot of zeros. Now, if we got a power here like 27, where we'd have a ton of zeros at the end, then we wouldn't want to write that out. Okay, and we talked about that when we talked about scientific notation, how scientific notation is good to write, really big numbers. So either one of these two answers would be acceptable. Okay, let's move on.